and everybody else is here? Okay. So now we're recording. Sorry about the delay. But for those of you guys that are just joining us, I did have the kiddos compute their raw score on their practice exam. The raw score is found by, which is down here called the composite score. It's found by taking how many multiple choice you got right times 1.2. Don't round, leave the decimal. Calculating or adding up all the different points that you got from the FRQs, which are all worth 1. They're always worth 1. I'm not sure why they make a big deal about it, but whatever. All the ones times 1. And then you add all of your FRQ points plus all of your multiple choice times 1.2. And then that puts you in a certain range. And I had them choose or identify on their test what range they were currently in from the mock exam. We're going to go ahead and go through questions that you guys have about grading. First of all, if there's any grading questions, because let's just say you guys want to give yourselves grace, right? The AP graders can't. Okay? You guys want to give yourself grace, the AP graders can't. It's very cut and dry. It needs to be very objective, not subjective, which is why the FRQ guidelines are what they are. Meaning, just a quick example, if I was to go to your FRQs, which are these ones, right? Scoring guidelines. Let's say, here's an example I used with AB. I actually had the same FRQ. This is an AB FRQ, FRQ1. Let's say you got 0.442 or 0.443, but you wrote the integral without a dx. Even BC kids do this. If you wrote the integral without a dx, even if you got the right answer, what are they going to do? Take off a point because you wrote it incorrectly, right? So you have to grade yourself harshly so that you're not making little mistakes that are going to take points away or answers away from you, because they have to say if there is incorrect work shown, I cannot give them all the points. Or, did you guys have the separable differential equation one? Solving?
Yeah, it's number 4.
It's nice, except if you didn't show separation of variables, you weren't allowed to get any points. Or if you separated wrong. Now, this one was only 5. Other FRQs, it's been 6, 7, or even 8 out of the 9 points that you would have gotten 0 from if you hadn't. But I know plus C. If you do illegal separation of variables, or if you do not do separation of variables and start integrating, you weren't allowed to have any of those points, even if it matched up. So you have to grade yourself harshly. Are there any questions as you guys were looking at the FRQs as far as the grading was concerned? Not just the concept, but the grading was concerned. Okay, so we were able to do number out of 9 and then add them all up and we're okay? We have the raw scores okay? Okay, so let's go ahead and let's start with FRQs because you guys were just talking about them in groups. What was one of the first tricky parts that you're like, I'm still not even sure I'm solid on? Or you're like, I definitely had to review to get there? Yeah, Corey.
Number 3,
part B as in D as in delta. Okay. Number 3, what was given? They gave us an implicitly defined curve, right? It's in terms of y. Both of them are in terms of y. They gave us shading, so we should be thinking right away, probably something to do with having to do with area, maybe even volume, and then, ooh, wait, it's a BC question, polar? Okay, so then in part D, use a polar equation given in part C. All right, so what did they give us in part C? They gave us the curve in rectangular form, but then they went ahead and they gave it to us? Look at you guys, spoiled rotten. You could have figured that out. Anyway, they gave you a nice polar form, a nice conversion, okay, for curve C. Use the polar equation given in part C to set up an integral expression with respect to the polar angle theta. So it needs to be d theta, that's all it's saying. That represents the area of S. Now, hold on, think polar. Polar area, aren't we going to measure out a radius? Right? Measure out a radius from the pole, true. What angle does it seem like we're going to start with? Seemingly 0. It's a non-calculated problem. Maybe we should double check that. But then going until, wait, how do we do the line? The line needs to be the upper bound. Ooh, so I need the line to be an angle? Okay. So how do I do that? First of all, if you plug in 0, Cosine is 1 and sine is 0, so 1 over 1 is, does that make sense with, okay, theta equaling 0 can be my lower bound? Okay, that makes sense. But I need my upper bound. My upper bound, I need to find theta where the line and the curve intersect. Or do I?
It's calculated just as down the
Question. Don't I really just need to know the slope of this line?
The slope of which line?
5/3 y. Couldn't I say it's the same thing as y equals 3/5?
Yeah.
Doesn't that mean that I have a rise over run of, no, careful. Yeah, 3 over 5. How do I find the angle where I have my, yeah, I can just think of tangent being 3/5, so I can do tangent inverse of 3/5. Kyle, what's up, bud? Oh, I was just thinking of making it easy on my brain, and my brain says, hey, let's get the slope to the other side, and now I can say, hey, the slope of the tangent line is 3/5. I was just making it easier on my brain. And I said tangent line, technically the slope of the line, but the slope, remember, is concurrent with the tangent when it's a linear function.
Because 3/5 is like, according to the it's against dx dy, not dy dx. So
No, it would be d dx of both sides. It'd be dy dx is 3/5. Dx dy would be 5/3.
but it's a case of dx dy is 3/5.
I wasn't even going through the rest of the FRQ. Hold on. And the value of dx dy. Oh, no. That's of the curve, kiddo, not the line. That's of the curve. There you go. There you go. That makes way more sense. Okay, sorry. So then we were talking about how to relate the line to tangent. Well, we can say that the slope is 3/5, and therefore the tangent is equal to 3/5. And so we could do tangent inverse of 3/5 if we had a function. Coming back down here, since we don't have a calculator, we're not going to solve it, but we are going to make that our upper bound. So tangent inverse of 3/5 is our upper bound. Our lower bound is 0.
We do have a calculator.
No, it's number 3. Oh, this is 2003. Lo siento.
It doesn't say to solve for it, though. It just
Just a 0.
Okay. Which means that you don't even need to solve for this angle either. Does that make sense? But if you were to put in your calculator, you would have to actually throw in the tangent inverse of 3/5. But you wouldn't actually need to find that value. And guys, this is trig. It's not unit circles, so they don't expect you to be able to do that mental math. Katrina.
Can I ask a different question? Can you
I think, Corey, is that good? Good. Yeah.
number 1 part B?
B.
B?
Okay. Number 1 was the area of volume one, right?
Yeah.
Okay, so we're talking about this one, yeah?
Yeah.
Why? Someone explain to us why this is complicated. So many AB kids would have hated this, and BC, it's still rusty. Why is B hard? What did they change, or what did they add?
Horizontal.
And it's the horizontal line that's above.
That's why.
Well, you have to, wait, pause. Pause. You know what to do. You have to draw this, guys.
Well, I saw the line at 1, and I was like, they're
Nope.
being nice to me.
So remember, y equals 1, y you can fly. Y is going to be a horizontal one. Okay? Or think about it, it's a tick mark on the y-axis. That's a horizontal tick mark, not a vertical tick mark. And as soon as you show this, A, we should know it's a washer because there's hollow space, and B, I changed, listen, I changed how I taught this to AB this year. Okay? Very slightly, but let's see if it helps. I said whenever you're trying to draw a radius, to draw the representative rectangle, the slice, the sliver, whatever that you're trying to show top, bottom, right, left, I told them always start with revolution, always start with the axis of revolution. And I think I basically said that last year. I made a much bigger deal of always go to the axis. Where is it? Right here. Go to the outermost. It could be above. It could be to the right. It could be to the right, to the left, and below. It doesn't matter. Always start from the axis to the outermost of the shading. Where is that? Right there. Big R. Big radius. Go back to the axis. Is there hollow? Yes. Go to the edge of the hollow. Go to the inner edge of the shading. I have my big R, my little r. Hence why I have 1 minus, who's this function? It's the exponentially guy. There he is, e to the negative 3x. And there we go.
If it were to be around that one that I did wrong, would I have had
It would have been messy.
I changed everything to D to Y.
And you would have had to, right? Because it's a vertical, which means that I have a depth of dy. I would have had to go from 2, which is great, only up to this bound, and then from 2, which is great, but only up to that bound. So you would have had to have 2 different integral expressions for your right-left. It would have been not a washer, it would have been a disk because it's flush. But you would have had to get everything in terms of y. And split up the integral. And it wouldn't match the other. They're not the same figure, so it wouldn't be the same volume. That's the sad thing.
And then, and then you don't have to get 2 different bounds because...
Yeah. Lo siento. Yeah.
When they find the intersection and they call it T for the rest of the problem,
Yeah.
if you don't do that, like if you actually...
You need to write out that whole decimal every time you use it.
So even if you cut it off like at like the 7, it's still wrong.
Give yourself a point on this FRQ. I wouldn't tell you that they would mark it wrong, but let's just go ahead and perfect how we do it by the AP. Does that make sense? So state it once with all of your decimals, and then be able to use it the rest of the time. You can call it T, you can call it S, you can call it A, B. They just probably use different letters based on, it was like R, S, T. I think that's what they were doing, but it doesn't matter what letters you use. Well, what are they doing? They're saying, I don't know if you're going to make me stay in dx or go to dy at some point, so they're just thinking ahead and being ready. Instead of having to go back and be like, oh, crud, what was the y? I didn't even think about it. Why not write it and have it just in case?
For the
Yeah.
first point where it says correct limits in integrals, so it doesn't matter which one. Like if I got the correct limits in A,
Nope, sorry, it has to be, well,
this is or.
yeah, it's a good point. Sometimes they say and. I apologize, I didn't read it. Yeah, as long as you wrote them once, you should be okay. For this one point. Hold on. What's going against everything that I think? Because if you write it incorrectly, the point is now null and void. Correct limits in an integral in A, B, or C.
So at least once.
Yeah, I think you're right. I think it's at least once. But, of course, we want it right in all of them. Yeah, Gabby.
Like, let's say sometimes you messed it up on the calculator and you got the wrong points, so then your limits are messed up and everything is
You would miss this point, but you would definitely be able to at least get the still setup right. And there is the possibility that they would give you, as long as you solved it correctly, the answer right. I wouldn't bank on that, though. Be careful. Because I don't see the AP graders getting out their graphing calculators and putting it in just to make sure that you did it correctly for however many thousands of kids make that mistake. You would at least be able to get these points. Does that make sense of the setup? I usually give you those points, and I usually don't give you the final answer just because I want to be like, hey, it's important to get as many points as possible. So have it as perfect as possible.
They wouldn't mark off and show the word the answer, right?
The point is what they're going to look at. They're going to ignore all of your decimals, and they're going to say, what do you have written down in the first 3 places? And if it's point, did it round to 3 or 2? 3. Yeah. So if they look at yours and you have a 442, they don't even care what comes next. They're giving it to you. Does that make sense? But if you were to write .441 and have it wrong, it would be wrong. Okay. But yeah, it's totally fine to write as many decimals as you want. Is there another FRQ part we want to look at? John? Context of 2, parametric motion, yeah? Right? Context of 2, parametric motion. Yes, they gave us a graph, but they also gave us expressions. An expression for x prime and notation for y prime. That's lame. Okay, line C. What have you done so far? You figured out signs of the derivatives of y prime and x prime. You've talked about the slope of the curve dy dx at point B.
Explain me.
B? Well, remember slope of the curve, that's dy dx, right? Which would be y prime over x prime. Y prime, they say, is it not, hold on, what's the graph of? Is this its position? Particle travels along the curve. Oh, it travels along this curve. Okay.
It's going backwards towards the origin.
You go A to D.
Thank you, thank you, thank you. Got it, from A to B, and then to C, and then to D. Okay, so my particle is going this way. We're looking specifically at point B. And it says the slope of the curve is undefined, which is pretty obvious because it's a sharp point. But then if it is undefined, then you can think y prime over x prime is undefined, right? What definitively would make that undefined if x prime equaled 0? Remember, sometimes the y prime might have a denominator also. But if x prime is equal to 0, then we could say that definitely is undefined. So that's going to occur when x prime equals 0. Well, don't we have an expression for x prime? Can't we graph it between 0 and 9?
Yeah.
Seemingly, because that's a D. We can make our window between 0 and 9. This will be a y equals, so the t's will be like x's, but we can go ahead and find the zeros of that function between 0 and 9. And was there only one 0? Okay. Oh, and you could have solved it even without using a calculator, but you could have also used a calculator and you would have still found 3. Yeah. Does that make sense?
Yeah.
So then part C. The line tangent to the curve at the point x of 8, y of 8, which they haven't necessarily attached yet to anything. Okay. Has to be somewhere in this region, though, from A to D, probably closer to D. Has an equation of y equals 5/9 x minus 2. The tangent. So we know right now 5/9 is the derivative, right, at 8? Y prime over x prime. Y prime of 8 over x prime of 8 is 5/9. Find the velocity vector and the speed of the particle at this point. Okay, so velocity vector, don't I just want y prime, x prime? Sorry, x prime, y prime. And then speed, then I have to do the magnitude. If you couldn't figure out the velocity vector, still something. Still say x prime of 8 and y prime of 8 and put answers, and then what are you going to do to those answers?
You're gonna square them.
Do the magnitude and say, like, I know what I'm doing, and they'll give you that point, even though they take off that point. Just AP strategy. But coming back, find the velocity vector and the speed. So then you were able to just plug in 8 to x prime. True?
Yeah.
And then couldn't you, after you plug in, if you know that y prime of 8, and you can solve for x prime of 8, can't we then just go ahead and plug in and solve for y prime of 8? So it was a, hey, let's get x prime of 8, then we'll go ahead and find y prime of 8. So once we plugged in, here we go, and got -9/2, then you can plug in -9/2 for your x prime, solve, 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 and you'll end up with your final y prime of whatever's left, and then magnitude. Got it, done. Did you have to get that decimal? Heck to the no. You box it and you'd be done. Did you have to get decimals? No, put in the fractions. Sorry, go ahead.
For D, I didn't write it as integration is net change, and I think I just left it out because of that. But I got the numbers, and I just did the integral from 0 to 9 at x prime.
Okay, so you didn't show this wrong, you just didn't show it?
Yeah.
That's okay. Should have been okay. Let me see what they said. How far apart are the points?
But I didn't show it because I didn't know I was supposed to.
You didn't need to show. They said how far apart are the...
I think it's question 2.
Thank you. I didn't know where I was and it moved. This is displacement. They're showing displacement. But doesn't that also mean displacement? So you're okay. It's just a synonym. Yeah, you're totally fine. So it said the integral. It didn't actually give a point for that FTC anyway, so you're okay.
So it wasn't integration?
No.
That's good, because I never know what's
Well, they didn't give you, okay, pause. Guys, what in the wording, you guys help out, what in the wording made it so that it was just talking about displacement, not final position? How far apart? All it cares about is the distance between. Does it care where it's at relative to some other location or position? No, doesn't matter. So it's not asking where is it at, which you would need to consider where it started from and the displacement. It's just saying how far apart, just displacement. Does that make sense?
Yeah.
Okay, any other FRQ ones?
60.
60. So this one's for sure non-calculator.
Yep.
But you guys remember, in the olden days, there were 3 and 3. Now there's 2 and 4, right? So that's why there were 3 calculator, 3 non. Now there's 2 and 4. 6, you're given a power series. It's an alternating series. That's how you guys were able to talk about error in letter B with the alternating series remainder theorem. Letter C, though, okay. Whenever I see this, show something as a solution to the differential equation. Could they be asking me to actually solve this differential equation? Could they, in general? Yeah.
Yes.
But check this guy out. This plus ruins everything as far as what we can do by hand. Because if you were to make this a dy dx, right? How would you separate? Multiply dx. Well, great, but isn't that going to have a dx? And then subtract, and then the y, but how do you get rid of the y? And if you divide the y, then all of a sudden that's going to have a, there's no way to separate. So some of you might have thought you were supposed to solve, but they didn't say solve for y equals f of x. They said show this works. This is impossible to integrate by hand. Show that it works, I must be plugging in stuff. So plugging in stuff, well, I need y prime. All right, cool. Let's find y prime. And y prime is equal to negative 2x over 3 factorial plus 4x cubed over 5 factorial minus 6x to the 5th over 7 factorial. Yes, I know you can go canceling stuff. Just don't do it yet. It's not pretty canceling. I have to take that y prime multiplied by x. So I'm going to end up with negative 2x squared all over 3 factorial plus 4x to the 4th all over 5 factorial minus 6x to the 6th. Now, yes, I know there's more, but life's too short, right? Okay. I have plus y. Well, stink. Who's y? That guy. So it's 1 minus x squared all over 3 factorial plus x to the 4th all over 5 factorial minus x to the 6th all over 7. Wait, I have like terms. Oh, put those together and you end up with, well, there's a 1. Minus 2 minus 1, that's minus 3x squared all over 3 factorial plus 4 and 1 makes 5x to the 4th all over 5 factorial. Hey, what do you notice about the coefficients now?
Whoa!
They cancel.
Cancel. It's like cosine.
They reduce, and what's left?
Where'd you get the y?
I found it. Derivative of 1 is 0. Derivative of a power, bring down. Derivative of power, bring down. Then I multiplied by x, so all of my x powers upped. Then I had to add it to the y, and I combined like terms with coefficients. Then I simplified my factorials and said, oh, hey, it's cosine. Dun, 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 dun.
You have to make it that.
Let's look at the answer key. Sorry, that was just how I did it.
Because the way to grade it is like 8.
Find the y prime, find the xy, find this and this and this, and then get it down to here and say it's cosine. Oh, that works. You were looking at this one probably, right?
I did.
It doesn't say you have to put the nth term, so I think it was enough just to find the, I mean, you could have put the nth term, but I don't think it was necessary.
It's okay. So I did the second way.
Take the derivative and then,
No, I just figured out that it looks like sine of x of x.
oh, but you showed,
Because I look at the series and I recognize that it could be.
yeah, no, it's good that you recognize sine, but you finished justifying, right?
Yeah, I
To get to
derived-
cosine?
derived
Okay.
to get to cosine.
Okay, that's all right. That's all right, so both ways are okay. Any other FRQ parts? Okay. Here's what, we only have a few minutes left. Here's what I want us to do for kind of getting an idea of where we're going this week. We just did a mock exam. Are there more? You guys know I have plenty, right? I am going to put another one up into your AP exam review folder. However, it's going to be optional because we don't have tons of time before Saturday. Does that make sense? So we are going to do another practice exam after we get back, well, after we take the mock exam. We're probably going to work on think there's a new one that was released, 2013 or 14. I think that was just released this year, but I haven't even looked at yet. I haven't seen. So we're going to work on one altogether. There's going to be another required mock exam or practice exam after the mock AP while I'm grading and I'm figuring things out, because you guys can't necessarily work on that right away, right? However, I didn't want to require one this week just because of time. But what is required? The when you see you think. So I want you guys for the last 10 minutes of class, or the last 8 minutes of class, grab out the when you see you think. So I want you to turn specifically to the BC content, even though the AB content is good. I'm going to go ahead and find a practice exam to put into your folder. I'm not going to put all of them up there, but I will put some more. And I'll call it optional pre-mock exam. Now, you can do it after the mock exam for the same extra credit, but some of you might want to print it out and be working on it now. I'm going to have you guys go ahead and pass up your practice exams, and I'm going to spot check and also get down the raw score just so I have an idea. I'm not grading you based on that raw score at all. And then tomorrow, we're going to actually work on last year's. Tomorrow we'll work on last year's FRQs. And I'll get them printed off for you. Katrina.
Is there going to be a day where we go over the multiple choice and can ask questions on that?
Actually, we might do that tomorrow. I figured that we're going to have a lot of questions, so I thought we wouldn't have tons of time of class.
Okay.
Yeah, let's go over multiple choice questions tomorrow. We'll start with non-calculator, then we'll go to calculator. But let me go ahead and spot check them and get them back to you. And if you guys did miss multiple choice, some of you haven't had time to try to even correct them. I mean, you graded them. That doesn't mean you tried to correct them. So what could you do tonight? Work on your when you see you thinks and try to correct some of the multiple choice if you haven't yet attempted that. Does that make sense? Okay, cool. Go ahead and pass up your APs once you have time. There is a big old box of paper clips because maybe a stapler isn't going to cut it, and that's totally okay. So brainstorm.